going to go over the area between two curves, how to find the area between two curves. This is part A and part B. In part A, the boundaries are not given. In part B, the boundaries are here. The first thing you want to do, you're given two curves, is you want to graph it. And because the boundaries aren't given, you need to find the points of intersection to find out where the limits are or the boundaries are at. So here, after I graph it, I can see the top curve and the bottom curve. The top is the blue one, and the bottom one is the red one. And I need to find the points of intersection, and either you use your graphing calculator to find the points of intersection, what the x values are, or you could use simple algebra by setting the two equations equal to each other, solving for it. Here we use factoring, and then we find out that x is equal to -4/5 and +1. So those are the x values where the two graphs intersect. So that's going to be our A and B. In other words, our boundary points for this graph. Now they're asking you to find the area. So one big thing you need to know to find the area, you need to find the antiderivative of the top function minus the bottom function. So the blue minus the red. So here, the area is equal to points -4/5 to 1, so A to B. Remember, the smaller to the larger, and then the top curve minus the bottom curve. And then once you have that, then you could go ahead and make it look pretty before you find the antiderivative. Make it look pretty, combine like terms. You're going to find the antiderivative, right? So you add 1 to the exponent and you divide by the new exponent. You have it going from -4/5 to 1. Now we use the fundamental theorem of calculus where we plug the 1 into the function minus you plug the -4/5 into the function. And once you do all that, you simplify, you get 4.86 units squared. Now the second question is a little bit harder because you have a graph that kind of crosses over. They tell you to find the area between the red curve and the blue curve. So here I graph in my graphing calculator and I get this. And it says between 0 to 1. So here they tell you the boundary points from 0 to 1. But notice from 0 to 1, they crisscross, right? The graphs crisscross. So here, when we find the area of this, we need to find out the area from this side and the area on this side. So the point of intersection between these two graphs is going to be it's going to be 0.5. So very similar to the other problem of how we did that. Either you use your graphing calculator to find the point of intersection or you set the two equations equal to each other. But 0.5 is the point of intersection. So first we find the area of this because the blue minus the red, that's going to be the area, the antiderivative of that. And then here it's going to be the red minus the blue, so they crisscross. So that's why I have two integrals going on here. Here goes from 0 to 0.5, the blue minus the red, plus the antiderivative of 0.5 to 1, so 0.5 to 1 of the red minus the blue, Again, I go through the work of making it look pretty first, combining like terms, and then I do each one at a time. Here, I find the antiderivative. Again, you add 1 to the exponent, you divide by the new exponent. Let's do the same thing with this. And then I simplify it to make it look pretty. And then I evaluate it using the fundamental theorem of calculus. I put 0.5 in, and then minus, I put 0 in. Well, if you put 0 in here, this whole thing becomes 0, so you don't have to worry about plugging that in. So if you put 0.5 in here, you get 1.25. This one, I have to plug 1 in. So when I plug 1 in, I get 1 minus, I plug 0.5 in here. When I plug 0.5 in here, I get -1.25. I simplify it, I end up getting 3.5 units squared, and that'll be the area of this entire graph.